Yeah, Bob did it again, gang. Good morning, or whatever time you got going for you right now. It is Bob in 1KPR, and this is the last part of my nostalgia for the old Q multiplier days, where we've done peak and notch filter. If you recall, we were talking about the old Hammerland and Allied and Lafayette and receivers that had regenerative peak and notch filters in them, and we did this all electronically with solid state stuff, and not like the old days, but we'll look at that in a minute. Anyhow, this beast has been tested, and I'm happy. There's no tuning, no more tuning involved. Everything's working, and I'm happy with it. Very happy with it. So I'm going to go through this fast as usual. If you've seen this so many times before and you're bored, take a little nap, and then halfway through we're going to open it up and I'll show you the inside. All right, here we go. I'm starting here. This module, we can select one of 4 antennas. We get 4 B and C's on the back. And I put in a switch here that enables the incoming signal out of the switch. It's a center off, which means the signal's coming in. Right now I'm using the 160 meter wire antenna. It's tuned to about 1900 kilohertz. That's coming in here. It's going all the way through the system. It's coming up here. It goes through the impedance thing and then over to this toggle switch here. And I left this is a center position is wide open. That means this whole unit is sitting there with an open input waiting for something. And I did that because I wanted to see if any local pickup in the air was going to get through this plastic case. The case is all shielded now, but fairly well shielded, but I wanted to see. And as you can see on my S meter, I'm at 0. I'm up near 1 meg. Okay. And that 1 meg, by the way, is from a guy who's about 4 or 5. He's 3,500, about 3.5 kilowatts, about 5 miles away or something. So local pickup is not a problem. And of course, all the way down, red would be shunt. But it's just a good test thing. I didn't have to do that, but I figured, you know, what the heck? Let's see what this is like, just sitting there with an open input. So red is shunted input, green is connected. We've got an RF transformer. We could bypass it or not. I use this today to check what the impedance is roughly from the 160 dipole. Remember, it's tuned to 1900 kilohertz, and we're up here at 960. And by spinning this around between 50 and 300 ohms, I found out I'm somewhere around 150 ohms, somewhere between 50 and 150 by watching the S meter, which would be about right. We're at 1 meg and the antenna is tuned for almost 2 megs, so that's about right that it would be up there. I've got an attenuator, which is nicely calibrated. We could bypass this as well. It is now. I'll turn it on. I've got a preamp, also well calibrated. It's pretty much on the money. You go to those hash marks. 15 dB is 6 to 1, as you can see. 10 dB is 3 to 1, and so on. In and out. All right, here's the meat of the thing. If you looked at the other videos here, you'll see how I built these. The pre-selector, it's pretty much self-explanatory. You can whoops, I'm doing this with the wrong hand here, am I? No. Big fat hands, Bob. Come on. You can select the band you want. It's not easy. There we go. Okay. And the notch filter, same thing. Watch Bob's hands. All the way up to 30 megs. And down there to 30K. It's actually good to about 15K. There is overlap in the system. Obviously, if you're going to be going from, focus here please, if you're going like from 300K to 800K, and then you start the new band at 800K, you don't want that to be split perfectly, and it isn't. This 800 is actually around 900, and this 800 is about 700, give or take, I don't know, but they do overlap all the way up. So it's 8s and 3s, well, that's the way it worked out. And I'm using, well, we'll get inside, we'll see that. In the output, I've got a 4-way splitter in here. It gives you about a 3 or 4 dB loss if you want to come out into multiple receivers and have pretty good isolation. Right now it's direct, green is direct, and yellow tells you that you're taking a little bit of loss, but you're driving 4 receivers. And of course, power. Now I'm calling this the pre-selector Shortwave 3, pre-SW3. That's because it's the third version, circuit version, using varactors instead of air variable caps. This actually, in terms of circuit design, is the 7th one. And as you can see, we call it the LCR7 series. It's the 7th design, but the third version of this kind of esoteric model, if you will. And I call it a signal conditioner because it does. It really does that. All right, let's take a look at it on the radio. I'm going to, well, first let's take a look at the transformer here. I'm going to bring, there's the S meter there. I'm currently at 150, so I'm going to let you see what happens here. Alright, as we go down, we get a little more RFK, get it near mid-scale. Oops, I got to turn it on. Alright, here we're at 150. Oh, we went to 300. There's, where are we, 50? 25 ohms. 25? 50? 150? 300, we got a lot more gain. Oh, you know what? This is the end-fed. Sorry, it's not the 160. That would explain for the impedance jumping all around. Okay, well, the instruments don't lie. All right, we'll bypass that for now. Let's take a look at the attenuator. We'll shut the preamp off. Take a look at the attenuator. We're going to go up here, first of all. All right. Yeah.
Hey, Bob. Hey, Bob.
Okay, sorry about the interruption. That was Mayor's calling me that had an emergency phone call that was not an emergency. Oh, everybody thinks their problems are important. Okay, where were we? We're doing the attenuator, and we're up at max now, and I'm going to go over here, and I'll give you some signal on the meter. And I'm going to try, I'm trying to do everything with one hand here. Yeah, we're turning. No, I'm not getting a good focus on that. No, I'm not. Huh, that's strange. Alright. the attenuator. We got to come back to that. We put the preamp. Oh, okay. Yeah, I'm trying to do something with my left hand and my right hand, and my brain ain't working. Here we go. Oh, really overdriving the hell out of this now. There we go. I'm going to turn this up, 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 up. I wish I could get a focus. And we're going down, down, down. So you can see we can go from maximum signal to dead air here. And with the attenuator, I can bypass all that. We get some here. Well, anyhow, sorry, I can't focus. All right, let's do the peaking thing, which is on right now. Actually, that's probably why we weren't. Oh, I'm sitting on the peak. Sorry. All right, we go back to the attenuator. There we go. And I'll bring it to full scale. See, without a rehearsal, this is what happens. And turn the attenuator, blah, 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 down. See? Yeah, before I was fighting the peak thing, which is giving me like 40 or 48 dB of gain, so no wonder this thing didn't want to work. All right, I'm switching over now. Trust me. I see I pinned it to the preamp. And here's the preamp. All right, so everything is working copacetic, as they say. Now we can put the pre-peaking thing in. I don't know where I am on the scale. Let me just give you a couple of dB, and I'm going to tune. All right, I was on the peak. We'll bring it back to full scale. And I'm going to ride off of the peak. There, see? I turn to get the other way, go back into the peak. You can get, I actually pinned it. You can actually pin the needle. All right. I shut that down. I'm going to go over, turn on the notchy guy. We're really peg the needle there. Well, it's very touchy, but I'll pull that back. Well, I'm getting glare today. I wasn't getting glare before. All right, I'm tuning through the notch thing. I really apologize for this. We're going off the notch, and I'm turning toward the frequency down, right down to dead air, just about. It is a measured 48 dB, and the peaking, depending on where you are in the band, or which band you're on, is anywhere from 60 dB to 36 or so, at the higher frequencies. So that's it. Again, then the four-way is in here. So you have the four input guys. Here's the four output guys. Here's the independent one. Okay, hang on. I'm going to take the top off. Not my top. All right. We got the top off. That wasn't so bad. And there it is. You can see it's all copper clad. Nice. And if you will notice, if you look in the other videos, I've got some spring, music wire springs coming out of here. See them? And they contact this thing, so that gives us continuity. And let's go inside here. That light helps or hurts. If you looked at the other videos, here's the peak and the notch circuitry, along with the varactor capacitors working against the coils where we established very low impedance for these reactors to work in the peaking circuit, series resonance, LC, and very, very high impedance here for the parallel LC to work in. There's curves and graphs in there. You can see why we do low impedance for series resonance and high impedance for parallel resonance. In this can here, and you can see the little springs I have soldered in there, is the preamp 15 dB, very nice and linear, very good at not overloading, low noise. Here's the output splitter, or the multi-coupler, if you will, going out to the 4 outputs. Here's the single output, which comes all the way back to the switch. Input protection. There is no DC continuity from the input connectors to any of the circuitry we go through here. We've got the back-to-back diodes. I've got a bleeder resistor. I've got an NE2. I've got about 1.5 mics of cap to keep the DC out. So it's going to bleed off, arc over here or here, clipping, and blocking here. So on this blue output line, there will be no DC static coming in. Again, these are all in the other video if you want a better look at them. Here's a little toroid guy that's giving me, I'll go back, take another look at that. Maybe we will, maybe we won't. Well, I guess right now we're not gonna. But as you could see, it goes up, as I can see, you can't see. Hello. Well, it goes up to 600 ohms from 25. Hey, gang, you know what? This ain't Hollywood. I'm probably more like the porn producer of amateur radio. Here's all the wiring. It got a little involved because what I wanted to do was have those indicator lights. So that's extra. That's a lot of extra wires. But it's not that bad. You know, you draw yourself a schematic and you go one wire at a time and beep a boop, you got everything done. Here's all the inductors mounted on the rotary switch for the peaking guy, and here for the notch. Power supply, you hear me harping on this all the time. Big healthy transformer, more amps than you're going to need, and a lot more volts. I'm actually at 17 volts because it's 14 volt AC. My rectified DC is about 17 and a half, and we're going through a 12 volt regulator, getting a beautiful clean 12 out. The reason we do that is I want to chop down to 17 as much as I can to 12. That's it's a 5.5 volt drop, so any of the hash that's riding on the peaks is gone, or most of it. There could be hash, there could be switching diode transients, and there could be just, you know, solid state noise, junction noise. Here's the 9 volt regulator, which feeds the reactors. You don't want to go over 9 or 10 volts with those guys. The rest of the system is 12 volts on the button. And again, I'm coming out into a little pi filter. Here's the big cap and a small, you know, little ceramic, or that's a poly cap actually. I think these are 10 or 20 mics, and these are like 0.1s on each side of the coil. And we come out there to this little foil strip where everything is nice and clean. I was just measuring this this morning, and on the raw VCC 12 volts, I've got what was it? It was 2.5 millivolts of hash and ripple, And over here, I've got less than a half of a millivolt, 500 microvolts of noise on this pad here. And notice I also put a little bypass cap there just for giggles, because we're so far from the, we're about 7 or 8 inches of wire from the power supply over to here before we actually feed these modules. So before we go into the module, I wanted another bypass cap in case the line was picking up anything. But that it did it. It did it. It's the supply is very clean. This thing with no antenna on it, you put it on the scope and you don't measure anything coming from the output. And as I said, we've got that 3,500 watt guy across the river a few miles away. He's not getting into the case. As you saw, the case is shielded. We do a lot of copper tape on plastic cases. That's the new norm for me. If somebody wanted a perfect mil-spec one, I'd use a metal case, but we're not doing Tempest or Echelon. Matter of fact, if you want to read something interesting, look up Echelon and Tempest for radio standards, receiver standards. Kind of interesting. So again, we're double shielded here, and then I've got that thing with the shield, so we're clean. And again, one last look without focusing on the front panel. And I did put a video up on how I make these decals. That's cute. I like that. See, you can sit in the dark, listen to your shortwave radio, and you don't have to read the numbers. You just watch the light where it goes. And again, red is off, green is go. And except for here, yellow means a little less than green. Full speed ahead. And of course, power. Goodbye. A lot of power supply, so you see those LEDs fade away kind of slowly. All right, that's it. Really long again, because Bob likes to talk. Stay really healthy, guys. This thing's starting to taper off a little bit. Looks good. We could see some light down the road. So, be good. We love you all in the hobby here and otherwise. And if you like, give me a thumbs up or leave a comment or something. And if you have any questions, please ask. We love to discuss these things. This is our hobby, after all. It's not our livelihood. N1 KPR on YouTube and Bob's America on the internet. You know the internet. See you later. Bye-bye.